Okay, today what we're going to do in this section of the class is we're going to learn how to write equations of lines. We've already done a little bit of that in the previous section where we've plotted some lines on the graph and we've looked at exactly the slope and the y-intercept and things. In this section we're going to learn about two different ways to write the equation of a line down on a piece of paper. The first one we've talked a little bit about, the second one we haven't. That's called the point-intercept version of the equation of a line. You're going to see this stuff is really not that difficult, it's not that bad at all, and you're going to see that it follows really logically from the material that we've already worked on. So the first thing we want to do is a little bit of a review. So if I write on the board here, what if I give you, just in the class here, two pieces of information about a line. The first is, I say the slope is equal to 4. Let's just say I give that to you. And then I also tell you that the y-intercept is given by 0, 5. And then the question is, on the test or the quiz or whatever is, given these two pieces of information, the slope and the y-intercept, write down the equation of the line. Okay? Just to jog your memory, the general form of what I consider the easiest equation of a line formula to remember is y is equal to mx plus b, where m is the slope, like we've already said, and b is what we call the y-intercept. Really, all you have to do is memorize that, and this is one of those things, I'm going to try to tell you the things I think you need to memorize and the things I don't. This is one of the ones you really need to memorize, and you will by working these problems. So by knowing that y is equal to the slope times x plus some number, b, the y-intercept, you can immediately write down the equation of the line. All I need to do is I say, okay, y equals, slope is 4, 4x plus, and all I need to do is figure out what is the y-intercept. And I've given it to you in the problem. The y-intercept is 0, 5. So the y-intercept is 5. Because remember, if I were to plot the point 0, 5, that's going to be up here on the y-axis because I'm plotting 0 and then I'm going up 1, 2, 3, 4, 5. So this is the y-intercept. That is the point that the line intersects the y-axis. And you could make a table or whatever the other methods that we looked at, and you could get all the points here and you could figure out what this line is going to look like. And you can see it's got a positive slope, which means it's going to slope somewhere this way. Rise over run is going to be 4 on the rise, and run is going to be 1. So if you wrote it down, you'd see that the line would go something like this. But what we're trying to do in this section is to write down the equation of a line, and that would be the equation of that line. So what if I gave you a little bit different piece of information? Let's say the slope is equal to -7, and the y-intercept is given by -2. Okay? The y-intercept is given to be -2. Well, it's very simple. Again, if I want to write the equation of this line, I just say y equals, I've got to find my slope, mx plus b. M is just given to me. It's -7, again, times x. And then I need to know what my b is, plus b. And b is just the y-intercept. I've given it to you. It's -2. So this number is going to be -2. So I can just rewrite this and say -7x minus 2. Because the b here, the y-intercept is a negative number, so I just pop that in there and then I get -7x minus 2. So you can see that once you get the general understanding of the equation of a line, and you know that the general form is like mx plus b, where m is the slope and b is the y-intercept, then you'll find out that if I can give you a few different examples here, and you can see that it'll be very easy to write the equation of a line. Let's say the slope is -3/5 and the y-intercept is 0, -2/5. Well, you can just plug and chug, like I like to say. The equation of the line is going to be mx plus b. M is -3/5 x plus b, which is the y-intercept. In this case, my y-intercept is negative, so I've got -2/5. And remember, when you look at this equation, all it means is you put a point at the y-intercept, which is negative 2/5, and then you use your slope to count rise over run, get your next point, and then you can just draw your line. Now, one thing I will point out is most of the lines we've talked about have had positive slopes. Remember, if it's horizontal, the slope is 0. As you start to slope upward, like this, you've got a positive slope. Okay, anything that slopes up like this is a positive slope. That's because rise over run, I'm rising a positive amount and I'm running a positive amount over to the right. And so when I do that division, I've got a positive number, so I've got a positive slope. Here I've got a negative slope. Okay, that means that you know, the rise is going to be negative and the run's going to be positive. So instead of, and I'm just kind of making this up here a little bit, but instead of rising positive and running positive, if I were to do this, I'd be rising negative and running positive. So the bottom line is, lines with a positive slope are going to go like this. Lines with a negative slope are going to go look a little bit more like that. Okay, so just to drive this one just really home, I mean, we can just do this one real fast. We can say, okay, let's plot this, x and y. Let's say y is equal to negative 2/5. Let's say this is 1, 2, this is negative 1, 2, 3, 0, 1, 2, 3, 4. And we'll just put some tick marks here. Okay, my y-intercept's negative 2/5. You know, that's somewhere right around here, just below the x-axis, but not yet to 1, because remember, it's a fraction. It's negative 2/5. My slope is negative 3/5. So what I'm going to do is I'm going to go down 3 instead of up. I'm going down because it's negative, so I'm rising in a negative manner. Rise over run. Okay, 1, 2, 3. That's my rise, negative 3. I got to run over to the right. 1, 2, 3, 4, 5. Okay, so it's something like this. Remember, I rise 3, 1, 2, 3, 1, 2, 3, 4, 5, like that. And then, of course, I could draw my line through them like that, and that would be my line. Now, notice when we did that, the line went like this, which is a negative slope. Okay, so you will find as you start doing these problems that equations with a negative slope go like this, equations with a positive slope go like that. And as you work more and more of these problems, you'll find out that you'll just memorize that. You won't even have to try to memorize it. You'll just kind of end up memorizing it on your own. Okay. Let's go ahead and move on to something a little bit different. The next thing I want to talk to you about is, you know, we've talked about the equation of a line. We've said, you know, one equation of a line is mx plus b. Okay? That's really the most common form of the equation of a line. There is a different equation of a line that sometimes is very useful, and that's called the point slope form of the equation of a line. Okay? And I'm going to write it down for you, and you're going to probably say, what the heck does that mean? And I'm going to explain it to you because it's really not that difficult. So let's go ahead and write it down. It's y minus y1 equals m parentheses x minus x1. Now this might look a little complicated, but it's not. And let me show you why. This m is the same slope as this m. So once you know m, which is your slope, you just plug it right in there. Okay? This form of the equation of a line, you use it to write it down whenever you have the slope and you have one of the points on the line. So that's x1 and y1. So as we use this version when we knew the y-intercept and we knew the slope. Notice that in all those other problems I gave you, the y-intercept, I gave you a point and it was like 0, 1. Well, that's a y-intercept. Okay, that's the point on the y-axis where this line crosses. So I could use this easily. But what if I give you the slope, like m is equal to 2, and I just give you some other point on the line, 1, 3, and I say, write the equation of the line of that. And you're going to, you know, without knowing this form, you're not going to be able to do it easily because you don't know what b is. You've got a point, but this is not the y-intercept. I mean, if you plot this, It's 1 up 3. This point that I've given you is not on the y-axis, so you can't really use this. But I'm giving you this, which is called the point slope form, and it's written that way for a reason. You have a point and you have a slope. And once you have those two things, you can write the equation of any line down. So let's do that. What if I give you, I want you to remember this equation. Try to memorize that one. That's an important one. What if I give you the slope is equal to 2 on a line, and just randomly another point on that line is 1, 1. That's just a point. This is not a y-intercept. This is just some point on the line somewhere. I can immediately plug in and use this equation. How do I do that? I just write it down. Y minus y1 means I look at my point that I have, I pick the y coordinate out, and I put it here. That's a 1. So y minus 1 equals m. I know the slope is 2, parentheses, x minus x1. I look at my point, I pull out the 1 there, and I stick it in my equation. So I write that down. And then I just simplify. Y minus 1, I haven't touched that side, equals, distribute this in, 2x, 2 times x is 2x, 2 times minus 1 is minus 2, so I'm given that. Now I want to get y by itself because you know the general form of a line has y over by itself, so I'm just going to solve for y equals, I'm going to add 1 to both sides, so I'm going to have 2x, I'm going to add 1 here, so I'm going to add plus 1 here, that's going to make this disappear. I'm going to add plus 1 here, which is going to give me minus 1. That is the equation of the line. So all I did is I knew the slope, I knew a point, and I plugged it in this equation, and I just kind of simplified it a little bit, and I came up with the equation of a line that looks very familiar. So the bottom line is you can go straight to using this form when you know the slope and you know the y-intercept. Like if you have a point like this, you know the y-intercept. You can go and use this form when you know the slope and you know some other point on the line, but you don't necessarily know the y-intercept. You just put it in there and you simplify. So let's do a few more problems to kind of make this stuff sink in. I'm going to write it again up here. Y minus y1 equals m times x minus x1. That's the equation. I want to keep it up here so that we can remember it. What if I say the slope is equal to negative 1/2, and I also know that a point on this line is negative 2, 4. Well, all I'll do is I just plug it in here. Y minus y1, I use the y for my point, is 4, equals m, which is given by negative 1/2, parentheses, x minus x1. x1 is the x coordinate of my point. I'm going to say x minus a negative 2, just like this. Okay. Next step, y minus 4, haven't touched that, equals negative 1/2, haven't touched that. All I'm going to do is I'm going to add the opposite in here. So I've got x plus 2. Remember, anytime you have minus a negative number, you can just add the opposite. You get x plus 2 in there. Next, I'm going to distribute this 1/2 in. I get y minus 4 equals negative 1/2 x. I just distribute the negative 1/2 into the x, minus 1/2 times 2 gives me negative 2 over 2, which is just negative 1. Think about that. Negative 1/2 times 2 is negative 2 over 2, which is just negative 1, like that. Finally, all I need to do is isolate y. So y is equal to negative 1/2 x, add 4 over here to get rid of this 4, so I add 4. Okay, so negative 1 plus 4 is what I really have over here. So y is equal to negative 1/2 x plus 3. Okay, so moving right along, we'll do another one. This one will be a little bit different because it'll have some fractions. Let's say the slope is equal to 7/5. Again, it's just another slope, rise over run. And I know that a point on that line is 3, 2/5. And this is just another point. It's just that one of the coordinates is a fraction, so it's not exactly on one of those hatch marks. It's kind of in between two numbers, two whole numbers. So it's simple. I just go y minus y1, which is 2/5, equals m, which is 7/5, x minus x1, which is 3. So I'm going to distribute the 7/5 in. X, 7/5 times x is 7/5 x, minus 7/5 times 3 is 7 times 3 is 21/5. And the way you can figure that out is 7/5 times 3, you just multiply the numerator, so 3 times 7 is 21. The bottom is just 5 times 1, so you get 5. Okay? And you've got that there. And then the next thing you need to do is get y by itself, so then you just add 2/5 to both sides. So you've got 7/5 x minus 21/5. I haven't done anything but write it again, plus 2/5 from this side here. So finally you get y is equal to 7/5 x minus 19/5. And that's the answer. Okay? So just to recap, you put it in there, you multiply through with your 7/5, distribute that in. The only real trick here is you've got a fraction times 3, and that's just simple multiplication of fractions that I've covered in the previous video course. So that's minus 21/5. Then to isolate y, you add 2/5 to both sides. It disappears from this side. Over here, it just ends up adding in here. Of course, this is a negative 21/5, so then you end up with a negative 19, and then of course it's over 5 because of the denominator. And in the end, what you're going to end up with is the same old thing, mx plus b. It's just your slope is a fraction and your y-intercept is a fraction. So we start from not knowing the y-intercept, not knowing any of that. We end up with the equation that we all know and love that tells us all that stuff. Okay. Now, the next thing I want to talk about is parallel and perpendicular lines, because you're going to be asked a few questions on that kind of stuff, and so on. And the first thing I want to say is, what do you think the definition of parallel means? When two things are parallel, it means that if you have a line here and you have a line next to it, okay, what does it mean to say they're parallel? It means that they go on and on forever, right next to one another. Here's one line, here's the other one right next to it, and they never touch each other. They never intersect, okay? The only way that can possibly be true is if these two lines never intersect, is if their slopes are equal to each other, okay? And that, when you think about it, makes a whole lot of sense. If you have a line going like this, and it has some slope, okay, and you have a line with a slope that's different, eventually it's going to intersect. And those are not parallel, okay? But if you have a line like this and another line that's parallel to it, they never intersect. The only way this can be true is if the slope of this line is exactly equal to the slope of this line. Well, then they'll go on and on forever. Okay, that is the slope. That's how you describe when two lines have a slope equal to each other. That's how you describe them. You say that they're parallel. Okay. Now, the other thing is perpendicular. What does perpendicular mean? Perpendicular means, let's say I have a line like this and a line like this. Perpendicular means the angle between them is 90 degrees. In other words, it's kind of a right angle. It comes straight in, straight on. If you have a line like this and a line like this, well, these are not perpendicular lines. I mean, it doesn't come straight on. This angle is less than 90 degrees, and this angle is greater than 90 degrees. There's no angle here with 90 degrees in it, and so this is not a perpendicular set of lines. But the questions they're going to ask you, they're not going to be drawing any pictures for you, and they're not going to say, hey, tell me if these lines are parallel or perpendicular. They're going to give you a few equations, and you're going to have to figure it out. So, remember this. For parallel lines, that means the slope are equal. The slopes are equal of the two lines. For perpendicular lines, okay, the product of slopes of the two lines is equal to -1. I'm not going to prove this for you here. This one here is very easy to understand. It's kind of, you've got the two things going on. The slopes have to be equal. This one is less easy to really think about. You should just sort of memorize that, and you can look that up, on your own at your own leisure to figure out why that's exactly true. But it's very easy to actually implement. Let me give you a couple of examples. Let's say that you have two lines given to you on some test or something like that. The first line is y is equal to 3x plus 2. The second line is y is equal to 3x minus 1/2. These are obviously different lines because this is different, but notice that the first part of it is exactly the same. The slope of this line is equal to the slope of this line, and so these two lines are going to be parallel. And just to prove it to you, I'll show you real fast. Draw your coordinate axis. The y-intercept of this one is at 2 with a slope of 3. So to get the second point, I go 1, 2, 3. That's my rise. My run is over here. My line is like that. Okay? For this one, my y-intercept, here's -1, -2. My y-intercept is -1/2, again, with a slope of 3. So 1, 2, 3 over 1 is right here. So I've got 1, 2, 3 over 1, and if I draw it very carefully, it doesn't look exactly right. 1, 2, 3. I think I just made my point a little bit off there. Then you've got your two lines that are parallel. Okay? Okay, let's do a different one. Let's say we have y is equal to 1/3 x plus 1, and y is equal to 3x minus 1. Are these parallel, perpendicular, or neither? Okay. Well, obviously the slopes are not equal because they're different. So let's figure out if they're perpendicular. So what we're going to do is we're going to multiply these two slopes together. 1/3 is the first slope times the second slope, which is 3, is equal to 3 over 3. 3 over 3. 3 times 1 is 3. 3 times 1 on the bottom is 3, equals 1. Now that's pretty darn close, but notice that they're perpendicular if the product of the slopes is -1. This is +1. So these lines are neither perpendicular or parallel. They're neither one. Okay, and I'm not going to plot these lines, but a general example of that would just be any old two lines. These two lines, they're definitely not parallel. They're definitely not perpendicular. They're just something else. They're two lines that intersect at some other angle. Okay? Finally, what if you were given y is equal to x plus, x plus 7 over 2, and y is equal to -x plus 2 over 7. Are these parallel, perpendicular, or neither? Well, the slope of this is +1. The slope of this is -1, so they're not perpendicular. Let's check and see if they're not parallel. Let's check and see if they're perpendicular. To do that, we multiply the slopes. This slope is 1. This slope is -1. You multiply those together, bingo, you get -1. Because the slope of this times the slope of this line is -1, these two lines are perpendicular. And finally, I'll just wrap up this section with one more example. What if you had y equals minus 3/4 x, and your other line was y equals 4/3 x minus 1/2. First question is, are they parallel? Well, the slope of this is -3/4. The slope of this is 4/3. They're different, so these lines definitely are not parallel. Let's check and see if they're perpendicular. The way we do that is we multiply the slopes. We say, okay, -3/4 times 4/3. Well, we can just do this very simply. 3 times 4 is 12. Of course, I've got a negative sign here, so I'm going to put -12 on the top. 4 times 3 is 12, positive 12 on the bottom, and that is just equal to -1. So these two lines right here are definitely perpendicular to one another, and that just simply means that they cross at an angle of 90 degrees exactly.